Hello and welcome. In this video I'm going to show you how to design and code a VBA application from scratch. In my previous videos I've shown many little known techniques, proven tips and tricks that you can use to make writing VBA code more efficient. In this video I'm going to put all these techniques together and show you how to use them when creating an application. Now you can download the fully working application and all the source code in this video from the link in the description. If you find the video useful and you want to take your VBA skills to the next level, then check out my course, the Excel VBA Handbook. You can find the link also in the description or go to the excelvbahandbook.com. If you liked the video, please click on the like button as it helps with the YouTube algorithm. And if you would like to get notified of my upcoming videos, then click on the subscribe button below. The first thing we're going to do is look at the application that we're planning to build. Now the most important thing when you build an application is that you're 100% clear on the requirements when you start. Because even a small change to the requirements later in the project can have major implications. So it's very important to be 100% clear on what you're creating. Now in our application here, we've got data, and the data is simply companies and amounts that they've spent. And what we want to do is we want to create a report, and this is in the columns F and G, and our report is going to have a list of the companies and the total amounts they spent. What we also want to do is, for any company totals greater than 150,000, we want to deduct 10%. And we'll do this application using a button. So when we click on the Create Report button, you can see that it wrote out the data on the right hand side. And so this is the application that we're going to be creating from scratch. So now we're going to go to the spreadsheet that doesn't have any code. So we'll close the spreadsheet with the code. And then this leaves us with the spreadsheet that doesn't have any code. And it's this one that we're going to be writing the code from. So the first thing we want to do is press Alt F11 and enter the Visual Basic Editor. And once we're in the editor, we go to the project at the side, we right click and we select Insert Module. Now the first module we're going to create is what we call click events. And the reason that we use a click events is this is where we're going to put all the subs that are kicked off or that are started when we click on a button. Now in this case we've only got one, but in the future if we increased our application size and added more buttons, we'd put them all here. So we do public, which means it's available to all subs and it's available to add as a button macro. We call it sub as it's a subroutine, and then we say create report. And one thing we do at the end that's very important is that we say click. So we can see straight away when we look that this is a click event. So again, that's an event happens when we click on a button. So what's useful about this in our code is that we're putting all the click events in one module. So they all go in the same module. So it's very easy if we later want to add or delete or whatever that we want to do, it's very easy to do this. Now the second thing that we want to do is that we don't want to have any code in our click events except for a line that calls a sub. And the reason for this is that in the future, it kind of separates our front end from the rest of the code. And in the future, if we change buttons, move them along, or if we decided that we want something to happen from an event, from like a worksheet event rather than a click event, it's very easy to do so. Whereas the opposite of that is if we have all these click events filled with code and then we change how they kick off or how they're used, we end up having to, it gets very messy and we end up having to copy a lot of code around. So from here, what we're going to do is we're going to call another sub. So this sub will be create report. Now we open another module, so we say insert module, and this module is going to be report. Now if we had lots of reports, we'd obviously call it something like customer report, but I'm just going to keep it simple in this example. And in this mod report, we're going to keep all the code related to this application. So this report we're creating. So this is public sub create report. And now we'll do a message box and we'll just get it to print out its name when it runs for the first time. So that just gives us an idea that it's happening. So let's press Alt F11, go back to the spreadsheet, and now we're going to add our button. So we do developer, we do insert, and we just draw the button here. Now the first thing it does is asks us to assign the macro. So we can cancel that and assign it at any point in the future. So we'll just leave that for the moment. And we'll just say create report. So we've got our button, and how we assign the button that at any point is we right click and we do assign macro. And then it brings up a list. So we can see very easily, because our sub has underscore click at the end, we can see very easy which one we're going to use. And we'll double click on this. So what that means is when we click on this create report, it will kick off the click event. So let's do that. And you can see that it brought up the create report. So let's just make this 100% clear in the code. We go to our click event, and I've just put in a breakpoint there, so the code is going to pause when it hits this line. We click on create report, and you can see that the code paused on this line. And we step through the code, it now goes into create report, and we keep going, displays the message box, then goes back and then just finishes. So we've set up here a very, very simple structure, and we've made it very neat and tidy. So now we've got the very basics done, let's look at how we structure our project. So we're going to do it in the create report. And first of all, let's go back to our application. So our application, what we're going to do is we're going to read through all the data. That's the first thing. Then we're going to take that data and we're going to apply a discount. And then what we're going to do is we're going to write out the data. So we can break it down into 3 parts. And the 3 parts are read the data, apply the discount, and then write the data. And so for all of these, we can create a sub. So the idea of having a sub is that the sub just does one small function. So a lot of people, when they start programming, they have subs and they can have like maybe 100 lines, and that's like really bad. What you want to do is have the subs to be really small, do one thing, and then it's easy call them from many different places, rather than having hundreds of lines and the same code kind of pasted everywhere. So we call, and we're going to set up a sub called read data. We'll call apply discount, and we'll call write data. So these are the 3 subs we're going to create. So let's create them, and we create them like this, just copy and paste. I'm just going to do a replace on the call. So I'll just replace, say, call here. So we'll do it like this. So replace this, and we want to replace that with private sub, and we want to do it in our selected text. Now I could just write it out, but it's just one way of doing it. And then we just press enter on all of these, and we get the end sub line. So now what we want to do here is we want to do a debug print, and we're going to print out the name. So this means that we can run the code, and we'll just see exactly if it's working okay. So now you might notice I haven't written like any real VBA code yet that's doing anything, but we're building up a very nice structure here. And as we're going along, we're testing everything, so it makes it difficult for bugs or errors to appear in our code. Let's do a debug print on this one. So before we run this code, what we want to do is use the debug compile. Or if we're writing like lines of code and we make a mistake, so we say, for example, dim I as. So what happens is the line is red, or if I have the syntax turned on, it will give me a syntax error. But we can have lines of code like this, say for I equals 1, 2, 4. There's no syntax error with that line of code, but the problem is there's no next. So if we do a debug compile, it will find this error. Now it found the variable not defined first, so let's fix the variable not defined error. Just say dim I. So we do run it again, and it finds the next one, for without next. So the debug compile is very useful because it checks all of our code and finds any errors that we have. Whereas if we run through the code, it will find errors, but only errors where we come across in the code. So another error that it finds, and this is, imagine we change read data and we change it now to read data 1. If we do a debug compile, it finds that error, sub or function not defined. So debug compile is very useful. So by writing code using debug compile, we're already getting rid of a lot of errors. We're just creating a simple structure. Every time we run debug compile, and as we'll see in a minute, we're going to test the code. And this makes it very difficult for errors to exist in the code, because as the errors appear, we can easily get rid of them. Now again, it's always interesting to see the opposite of this approach. So the opposite of this approach would be where you create a sub with maybe 100 lines, and then at the end you try and run it, and you start to get errors everywhere. And then you make a change and an error happens somewhere else, and you've got a mess. But if you build it in a manner like this, it's very structured, and we can deal with errors as they occur. So the next thing we're going to do is we're going to run this code, and we run it the way that will run when it's finished by clicking on Create Report. And let's look back in the immediate window, and you can see that it's printed out read data, apply discount, write data. So we've got a nice simple little structure that's coming together. So now let's get down to what we're actually trying to do here. So we're going to use a dictionary in this application. So just in case you're not familiar with what a dictionary is, let's have a look at the background to the dictionary. So we want to store a group of items, and a lot of times in applications we use an array. So an array here, it just stores a list of items like this. Now what we want to do is we want to store each item, but we want to also store the value, and we want to update that value. Now in the array we could create a two-dimensional array, and we could store the values like this. But the problem is that first of all, increasing or inserting something into an array is tricky because we have to resize the array and then we have to add the item. And the second thing is that if we want to update an existing value, we have to read through the array to find the value, and then when we find the value, we can update it. However, with a dictionary, it's much easier to do that. We can just access the item by its key. We don't need to read through it. So if we find a peach, we can say, okay, this is a peach. The value is 12. So let's add that to the 24 we already have, and then we put 36 in. And when we're doing the code, you'll see how simple it is. So a dictionary is like a real-world dictionary, in that the real-world dictionary, the key is the word, and the value then is the definition. And each of the keys is unique. Now another example is the old telephone directory, where a person's name and address gave a unique key, and then the value was their phone number. And the idea of both the dictionary and the phone book is that you don't read through the whole of each of these books to try and get the word you want. You just go pretty much straight to the word or straight to the person's name and address. Let's have a look at how the dictionary works, just a brief little example. So imagine we have a list of items here. So this isn't a dictionary, it's a list of items. And imagine we have date here as well, and we have other stuff. And what we want to do is we want to sum the values. So we read through the first thing, and what we see is orange 5. So we've sold 5 oranges on a certain day. Let's add the orange and let's add the value 5. So now we go to the next item, which is apple. Apple doesn't exist. So let's add the apple, and now we'll put 12 as its value. So now we move to the next one, which is orange 15. So orange already exists. So let's just add to the orange, and now we've got 20. And next we go to pear. It doesn't exist. We put it in our dictionary, and we put it in with the value 9. And finally we come to apple. That already exists, so we just add 6 to apple. So you can see that our final dictionary that we have here after reading the data has a sum of all the values. So that's why we're using the dictionary in this example. So now that we know that we're using the dictionary, this is the way that we're going to use it. We're going to declare the dictionary here. So the dictionary as dictionary. Now to add a dictionary to our project, we use Tools References, and we go to Microsoft Scripting Runtime. Now if you're using an Apple Mac, then this isn't available, but what you can do is use an existing class. There's a drop-in class for the dictionary that you can use instead, and then the dictionary will work in exactly the same way. We declare our dictionary. Now you might be saying, shouldn't there be a new there? Well, actually there shouldn't be. New is used when the dictionary is created, and we're not creating a dictionary here. We're going to create that dictionary in read data. What we're just going to do is use this as the variable, and we're going to pass it back. So we're going to say, set the result of read data back here. So because we're returning from read data, what we need to do is change read data to be a function, because a function returns values, or objects as it is in this case, and we say we're returning a dictionary. And now just to make things very simple, let's say we're going to create a dictionary, and then we're going to return the dictionary. So we're going to do something, we're going to read the data in here, and then finally we're going to return the dictionary. And we do that like this. We say set read data equals dictionary. So create the dictionary, return the dictionary. So that makes it simple, makes it easier for us to see what's happening. So after we read the dictionary, we want to apply the discount. And so what we're going to do is we're going to pass the dictionary into apply discount. So let's bring this up here. So we'll have by val, and that means we don't want the dictionary, the actual variable to change, as dictionary. So we're passing in the dictionary. Now, if we take the dictionary, if we pass in the dictionary and change it, it will be changed outside. But it's always better to pass it back because it makes it more explicit and more obvious in the code. So I'm going to make this a function, and I'm going to say as dictionary. Now we don't need to create the dictionary here. We're going to apply the discount, and then we're going to return the dictionary. So set apply discount, and that's going to equal the dictionary. And we're going to get it here. So we'll say the same thing, set the dictionary equal, apply discount, and we're going to pass the dictionary. So it's very obvious from both of these that we're getting back a dictionary. So it makes the code easy to read. And then at the end, what we're going to do is we're going to use the right data and we're going to pass it a dictionary. Now I'll leave call there. I like call because it just makes it obvious what it's doing. It's not required, but it just makes it clear that we're calling something. And then of course here, what we want to do is just put in right data here. Now we can get rid of this debug as we don't need it. So the first thing I want to do is do a debug compile. And you can see that there's no errors. Now one thing you might be wondering is why are we doing it like this? Well, the whole idea is that we're separating the read data from the apply discount from the write data. So the read data is kind of like our data layer. The apply discount is like our business rules, and the write data is like our output. So we're separating these. As far as write data is concerned, for example, all write data knows is that it's going to get a dictionary and it's going to write it out. So if in the future we read the data from, say, a database, or we created something to read it from a file, or we could read it in many different ways, it doesn't matter. Write data doesn't care where the source of it came from. All it cares is that it's in the format it's expecting, which is essentially a dictionary with a string as the key and with an amount as the output. So this makes the code very flexible. Now the opposite of this would be where we're reading and writing the data and applying the discount all in one go. And that code's doing different stuff and it's tied together. And in the future, if we wanted to write data out in the same way, our data code is tied to our read data, so it's very difficult to do anything, and it makes our code inflexible. And another very interesting thing here is that we can test these in isolation. So we can test read data, we can test apply discount, and we can test write data because they're all done separately. So let's step through the code and see exactly what's happening. And I'm going to put a breakpoint here, so our code stops here. And again, I'm always clicking on the button to run it because this is the way we're eventually going to run it. So it's good to keep testing. So at any point, if it breaks, we're aware of it. We click on create report. So that goes to read data. We've created a new dictionary and we're returning the dictionary. Then we're passing the dictionary into apply discount. We're returning the dictionary, and then we're calling write data and finishing. So our basically skeleton code is working correctly. Now we've kind of done the whole structure. It's very simple. We've done a debug compile. We've run through the code. So we know that there's no errors at this point, or it's very unlikely that there's any errors lurking. So this is very good. It means we're consolidating what we're creating all the time. And this kind of environment that's very structured, very well laid out, it makes it very difficult for errors to exist. So now we can go down and we can just concentrate on reading the data. Don't have to worry about anything else for the moment, because we know once we pass the dictionary back out, the code should still work fine. So we can just focus all our attention on the reading data. So to read the data, what we do is we basically create a range variable. So we do RG as range, and then we set the range equal to, and in this case, it's sheet data. So if you look in the left-hand side, you'll see that what I have here is data, and we have SH data. So the one on the right-hand side, in the parentheses, that's the actual name on the tab. So that's the worksheet name. And then the one on the left, SH data, is what we call the code name. So if we click on the actual worksheet there, you can see down below that we have the properties. And the top property name, SH data, that's what we call the code name. So we can change this here, and it will appear changed up there. Now the advantage of the code name is that if we reference the code name and the user changes the worksheet name, our code will still work fine. So, and we can also reference it directly. We don't need to use this workbook worksheets or anything like that. So that's the code name. We say range, and let's say A1. And then we say give us back the current region. And then what we can do is dim I as long, and then do a for I equals to range.rows.count. Now the reason we use 2 here is because we don't want to count the header, so we're skipping from the header. So this is something that's not really that nice, because anytime you use current region, you have to remember to start from 2. Or a second thing is that we could resize it, we could do an offset, we could do a resize, and we could resize the row so it doesn't have the header. Now that's possible to do, but because this data is in a table, so you can see that it's in an actual worksheet table, what we can actually do is we can say list objects, and we don't actually need the range at all. We just want to get list objects, which is the table on a worksheet. So it's called list objects. It's a bit confusing. So we click on this table, look on a table design. I've called it table 2. So let's call it something nicer, table company. And then when we call it table company, this gives us access to that table. Now, once we have the table, we can just say data body range. So that just gives us the data in the body range. So it doesn't give us the header, and it doesn't give us the totals row if there is one. So then we can just treat this as our full range, which is very nice. So once we have the range and we're reading through it, we just want to add it to the dictionary. Now we don't have to do what I'm about to do, but I like this. It makes the code very readable, and it's good when you're starting off with VBA. So we add the variables company. So company as string because it's text, and amount as a long integer. And then we read into these variables. So we say company equals, and to get the cell that we're currently dealing with, so it's in our range, it's a cell, so we use cells, and I is the current row, and then we want to use the column. So company is column 2, so we say dot value. So let's just have a quick look at the spreadsheet. You can see company is column B, and amount is column C. So we'll basically just copy this line, and we'll just replace company with amount, and we'll replace 2 with the number 3. Now when you're adding something to the dictionary, you would imagine that you'd have to do something like this. You'd have to say if dictionary exists the company, so if the company exists is not true, it doesn't exist, it equals false, then we have to add it. And we add like this, company, and we add the amount. And if otherwise, we would say dictionary, the company, equals itself plus the new value. So plus amount. Now the beauty of the dictionary is that we actually don't need this first part, because the dictionary, if it doesn't exist, it will automatically add it, and it will add our value when we use this line. So this line saves us a lot of hassle. This will either add the new item to the dictionary with the current value, or it will add the amount to the existing value. So this is very useful indeed. So let's do a debug compile. Everything is okay. So what we want to do next is we want to run the code. So again, let's just put a breakpoint here. And now we run the code, clicking on the button. And then when it stops, we'll just do a Shift F9 to view this in the watch window. So we just Shift F9, then hit add, and you can see our dictionary appears. So if you go down, you can see that we've got all the keys that are in the dictionary. Now this is fine, but what we want to do is we want to print out the results of the dictionary, because it's just very useful for us to see exactly what's there. And after we apply the discount, it'll become useful indeed. So let's create a sub, and we're going to call the sub print dictionary. And that will take the dictionary, and that will take a string. So we just print a header. So it's going to be after we read the data, after read data. So we can see the results very clearly. So we'll create another module, and we're going to call this module utils. Now we always use mod before the module's names, because if we have something else called utils and we call the module utils, it can cause an error. So it's always good to put mod before it so that we don't have that conflict. So we want a public sub call print dictionary, and that's going to take the dictionary as a parameter, and that's going to take the string as a parameter. And that's just, we'll call it header text as string. And so this should be YV. And so what we do first of all is we do a debug print, and we print out the header text. We do a new line first of all. So that'll just give us a bit of space. and then we do the header text. And then on the next one, what we do is we do our for loop. So we do dim key as variant for each key in the dictionary. We do the next key, and then we do, let's print out the key, which will be the company name, and let's print out the value. And the value, of course, is what's at that key in the dictionary. And again, always when we do this, we do a debug compile. Everything looks good. So let's bring up our immediate window. Let's delete what's in it already. We can turn off our breakpoint. Let's click on create report. You can see that it filled up. So it says after read data, and these are the values. So these are the sum values. Now what's prudent at this point is if we take this value, so say 45237 of Venus stores, and we just paste it down here, and then we get Venus stores, and we just check that the value is correct. So we can even put in at this point a totals row. So you can see that the values match 452357. So we know that our values are correct at the moment. So this is a very useful thing to do. So you'll notice in the read data that we have the numbers 2 and 3. So we don't like to have numbers like this in our code because they're magic numbers is what we call them. We come back to this code in the future and we're not really sure what these numbers are. And the other problem is if we decide to change the columns, say the columns move to 4 and 5, then it's very tricky because we can't just do a search and replace because there could be the number 4 and 5 or the number 2 or 3 used somewhere else in the code. So we'd have to go through the code and figure it out. So what we use in code is what's called enums, or we can also use constants, but enums are actually better when we're just dealing with numbers. So if you've ever tried to paste something, so we use paste, and what happens is we have all these options. You can see them listed here. Paste column widths, paste formats, paste comments, and so on. And all these are basically just represent numbers. But because we have them as a string like this, we can see very clearly, okay, this is pasting all. We can say, okay, this one is pasting formats. So it's very clear to us what exactly they are. Now, paste formats is actually just representing a number, and that number is -4122. So imagine instead of this, we have -4122. Not that obvious at all what it's doing. And we have to go and try and find what is it doing, even if it had a number like 3. Just something very ordinary. Still not clear. We still have to go and figure out what it means. But if we're using an enum that is a text version of the number, it makes it easy. So how do we add them? And how we add them is quite simple. So we go to the top and we're just going to have enum, and we're going to call it read columns. And then we'll end enum. And what we'll do is we'll say RC and we'll say invoice. Now invoice equals 1, that's column 1. The second one is company, and that's column 2. And the third one is the amount, and that of course is 3. So we can just take company here, we'll place it there, and we can do the same thing for amount. And you can see that the code now is much more obvious to read. So if you read this, you're looking cells, okay, it's the company, okay, it's the amount. And as I said, if we want to move company in the future, we just change it in one place. Now, of course, we do a debug compile, and then we run the report. And if we open our immediate window, you can see it appear. Now let's delete it. I always like to delete before I run it again. So it's still working fine. Now, one more thing about the enums. In this case, what we're doing with the enums is we're using them as columns. So the first one is 1, the next one is 2, and so on. So we can actually do this. We could actually say company equals company plus 1, and amount, that should be invoice, and amount then equals company plus 1. And this will work fine. And so the advantage of this is that if in the future we moved over all our table and we moved it to column 6, we can just change this to 6, and then everything else will update automatically. So we're just making a change in one place. So you can see this code is very flexible indeed. So now we know that we're reading the data and everything looks good because of our print dictionary. Now, one little thing we can do, if we want to really make things safe in our code as we're developing and we don't want any kind of hidden things jumping out and grabbing us, what we can do is use debug assert. So debug assert is very simple. So we give it a condition, and that condition will assert to be either true or false, and if it's false, if it ends up being false, then this line will stop. So if I run the code from here, it stops on this line because it evaluated to false. So if I say dictionary dot and I say count, so the number of items in the dictionary equals 0, it will fail because they don't equal 0, there's more. And we know then that there's a problem, so we can check our code. Now what I'm doing in this case is I'm doing count is greater than 0 because I want to make sure the dictionary has values in it. And we can say something, make sure that the dictionary isn't empty. We can say not dictionary is nothing. So that sounds a bit confusing, but we're basically just saying the dictionary is something. It's definitely not nothing. Now, this is only kind of temporary code that we use while we're developing. So if in the future we change something in our code, so for example, we've developed a lot more code and then we come along and we actually comment out this line by mistake, or we comment it out and we forget to put it back in, and then we run our code, straight away we're getting, hold on, there's a problem here. Sorry, that should be dick. So we run the code and straight away it stops there because the dictionary is nothing. You can see dictionary equals nothing. So I like to think of these asserts. They're kind of like, imagine our code is like a load of streets in a city, and these asserts are like checkpoints. When the dictionary comes along, the checkpoint is basically saying, okay, you're a dictionary, you must be something. And number two, you're a dictionary, you must have some items in you. And if not, then it stops. So this is good. It means that the code doesn't continue on past the error. So it's like checking at every point that everything's okay. Now we don't leave asserts in the code when we give it to another user. So we can use different ways of hiding them. But really, like when you're developing like this, it's fine just to have them in and then just take them out when you're finished. So we'll go back to fixing this up. And so at this point, we know. So we've got, yeah, so because it isn't anything. So let's just run this code again and we look in our window and you can see that it's fine. So everything is good so far. Now, what we want to do next is we want to apply the discount. And so we can do something similar after the discount. We can put this code in. We want to call it the print again so that we can see what the dictionary looks like. And we'll say after applying. So after apply the discount. So again, it's just in case we do something like forget to return the dictionary or we accidentally delete all the items in the dictionary. These assertions will make sure it didn't happen. And then we can check the call print dictionary to see exactly what's in it. So let's go to our discount, and this is what we're going to do. Again, we're just going to have a for loop, so we can actually just grab this for loop from here and we place it in. So we're running through the dictionary, and again, going to use a variable for amount. And this just makes the code a bit more readable. So we don't have to do it, but it makes the code readable. We're saying amount equals dictionary key. Anyone reads this code can see straight away I'm reading an amount, and we're saying if the amount is greater than 150,000, then what we want to do is we want the new amount to equal the amount, and that's minus, and then get 10% of the amount. So we're taking a 10% discount multiplied by 0.1. And we'll just make this C long, which is just basically rounding it up to a long integer. So we've updated the value, and then we do an end if. Now let's do a debug compile again. And then what we do is we run the code. So again, we'll run the code. Now before we do it, I'm just going to, again, empty the immediate window is empty. So create report. We can check and we can see that the value has been discounted. So you can see here that the value has been discounted. And so now we've got two parts done. We've applied the discount and we're after reading the data before that. And so now what we're going to do is we're going to write out the data. So writing out the data is very similar to what we've done already with applying the discount, in that we will loop through the elements of the dictionary. We use the same loop, of course, but obviously we're not updating the dictionary. We're just going to write it out. So what we need to do is decide how do we write it out. we want to have the row because we're going to be starting at a row somewhere. So row as long, and row equals 2 because we're going to be starting F2. Now again, this is a good case for using enums. So we can have read columns, we can have write columns, and we have RC company equals 6 and this equals 7. Now of course we have to change the name, and this is going to be WC for write columns. And then let's create another enum, and then the enum is going to be for our write row. So we can have, let's say, the header, and the header is going to be row 1. Now we're not using it in this application, but it's useful to have it because there's a good chance we'll probably use it in the future if we make changes. And then the start row is going to be the header row plus 1. Now in this case, it's good to have it equal to company plus 1 because it's always going to be one more than the company. And if that changes, we'll just add the new column in here and then update it. But it makes it easy if we want to change the value 6 to something else, and everything will then change. So row equals, and this is write row, and we're going to say the start row. And so at this point we want to write something out. It's going to be in sheet data, it's going to be in cells, it's going to be in row. The column is going to be, we already have the columns written out, so it's WC column, and that's company. And this is, and then the value of course. And then this is going to equal to the key. So the key, remember, is the company. And then the amount is going to be this one. And we'll make this amount. And that should be fine. Now, a couple of other small things. Of course, we want to add the row. So every time we write out something, we want to add 1 to the row. So that means it will write the value to the next row. Now, if you're not familiar with this code, so row assigned to row plus 1, what we're basically saying is, in the old days of writing BASIC, if you ever wrote it on a Commodore 64 or on a Spectrum or something like that, we used to have the command let row equal, which is the same, but we just don't use let anymore. So whatever's on the right hand side, we're basically saying let row equal the right hand side. So the whole right hand side is evaluated, and that value is put in row. But if you've been programming for any length of time, this is a very familiar counter where we just add 1. So we've done almost everything, but there's one other thing that's nice to do, and that is to clear the data. So we want to go clear the data before we actually start writing. So this gives us, and what we want to do is we want to have the header row. It will actually be the start row, and we want to do current region. And that gives us the range, and then we want to clear the contents. Now one thing is we don't want to delete the header, so we just move down 1 row. So offset 1. So just give us all the adjacent data, move down 1 row, and then just clear the contents. Again, we do a debug compile, and now let's run the code, and it should do everything that we expect. And you can see that it's filled up all the data that we expected. Now again, we can check the data, and it's always prudent to do that just to make sure that our output is correct, and then we know that what we're doing is proper. So one thing, now we have this working, one thing that I would do to make this code a bit better, we could, instead of just reading through a range, what we can do is we can put these values in an array. So we can do something like dim array as variant, and then array equals data body range, and we say dot value, and then we say for I equals, and we do L bound, and we do, so L bound array 1 to U bound array 1. And then instead of cells here, we just have array. And we just have array. And so if we're dealing with a lot of data, reading from an array is much faster. So again, let's try this code, and I'm just going to manually delete this to make sure that what we're doing is correct. So let's create the report and see that it worked perfectly as the array. And now if we have a lot of data, this will actually work a lot faster. Now one thing we should also be doing is we should be turning off our just a different Excel functionality like calculations to make things go faster. And I've got a class that just makes that happen. So we just do right click, and I'm going to import the file. And you can see Excel settings here. So we're just importing that file. And so let's have a look in that class. And so what that does is, very simply, it stores the settings. So calculation, display status bar, enable events, and screen updating. It stores those. And then, so we call back up to store them, and then it turns them all off. And then at the end, what we want to do is we want to set the settings back. We call restore. This really makes a big difference in speeding up your application. And turning off enable events is very important because it could cause your application to crash if the event is being called and a worksheet event is being kicked off all the time and you're not expecting it. So let's go back to our report, see how this works. We basically declare like this. We do dim and we do settings as new CLS Excel settings, and then we do settings the turn off. So turn off calls backup, and then at the very end we say settings and we say restore. And then when our code runs, it turns things off and then turns them back on again. And if we have like a lot of calculations and stuff like that and we don't want it to run, then it's very important. It makes a big difference to the speed as well. So we do a debug compile, and let's run this code just to make sure that it's running fine. So delete everything here. Always good to delete to make sure that something bad hasn't happened. And now that we're happy with everything, we can go back to this code and we can take these out because we don't need them anymore. We're happy enough. Our code is pretty solid at this point. Do a debug compile one more time. Run the code one more time to make sure we didn't break anything. And our application is done and dusted. So that's how to create an Excel VBA application from scratch. So this video was packed with a lot of information. So if you want to see this code and try it out for yourself, then you can download the code from the description below. Now, if you like this video, please click on the like button. And if you'd like to hear more about my videos or any upcoming videos, then please click on the subscribe button. And if you've got any questions, comments, or queries, please add them to the comments section below.